Okay, so I'm picking this up right here with the concentrations, pH, and acids base. So this is super common in terms of like what you might see on a test. So like the idea that you would find the missing piece. So you'll always have one of them. Find the missing one. Figure out what pH it is, and then identify that as an acid or base. So I'm going to walk through a couple of these, and then have you try a few on your own. So I'm going to clean this up a bit. So if you get the hydronium concentration, then you're good to go for pH. If you get the hydroxide, then you've got to find hydronium. So only this is going to find pH. So this is going to lead to pH. If you only have this, what you're going to find is POH. Now you could just take 14 minus POH and it gives you pH, but just be aware that pH is specific to the H3O plus or the hydronium value. Okay, so the way we're going to do this is we're going to take a look at what they give us, and in this case they gave us the H3O plus. Okay, so the way it's going to work is every single time you're going to do the same thing. So in your calculator you're going to take 1.0 times 10 to the negative 14th, and you're going to set that equal to hydronium, which is going to be 2.3 times 10 to the negative 4th. And then this is where the hydroxide goes, and that's going to end up being our x. So we're just going to replace all that with an x, and then we'll solve for x. So the formula I'm using is just right up here. Kind of clean this up a bit. And it's just right up here up top. So when I erase all this stuff I was drawing, if we just go over here, I'm just using this concept right there. There's your formula. 1.0 times 10 to the negative 14th, which we have here, is H3O plus, which I have here, times OH. And so that's basically what we're doing, okay? All right, so you're just going to run that through your calculator, and you're going to get a value for X, and that's going to be hydroxide. So we're just going to run that through our calculator. So we do 1.0 times 10 to the negative 14th divided by, and it's going to be divided by this, 2.3 times 10 to the negative 4th. So divided by 2.3, double E negative 4, I believe is what we said. Yep, negative 4. And then we're going to equal. So we got to get 4.3, or you can go 4.35, but 4.3 times 10 to the negative 11th. So let's go ahead and write that in. We got 4.3 times 10 to the negative 11th. Now, I'm going to tell you a little trick here. When you're doing these equations, you want the exponents. So we got negative 11 and negative 4. You want those to add up to negative 15. So negative 4 plus negative 11 adds up to negative 15. If the exponents add up to negative 15, it is most likely correct. Now, if you get a situation where you have clean values, meaning that there's no decimal, it's just a whole number like 7 times 10 to the negative 12th, something like that, where you don't have any decimal values, just whole numbers. If you have whole numbers, it will add up to negative 14. So basically, they better add up to negative 14 or negative 15, or they're going to be incorrect. And that's just the exponent value here, right? So just something that can kind of help you out when you're running through this. So let's go ahead and clean all this mess up real quick, put that back in there. So we said, I believe 4.3 times 10 to the negative 11th. Okay, now, pH. How do we solve pH? Okay, so what we're going to do for pH is we're just going to do this right here, the negative log of the hydronium. Okay, so this is the hydronium. We have to use this value over here to find pH if we're going to do it with the logarithmic function. Okay, so I'll show you two ways to do this. The best way is using the log. So what we're going to do is it's the negative log of whatever is over here, which is going to be 2.3 times 10 to the negative fourth. Now, it says that this is a negative log. So see the negative sign right there. But what you're going to do in your calculator is you're just going to put in the log function. You're not going to worry about the negative piece, and you'll just drop the negative sign. Okay, so we're going to do log of 2.3 times 10 to the negative 4, and that will give us pH. So let's go over here. I'm going to clear this out. We're going to hit log 2.3, and I believe we said negative 4. And we'll hit enter. See, here we go. We got negative 3.6. So remember, I said we're just going to drop the negative. So we're going to come up here, and the pH becomes 3.6. All right. So let's look at the other way you can do this. Let's say that you don't have, for whatever reason, you don't have that. You just have the hydroxide. Well, you can do the same thing. You could just do the negative log of the hydroxide. It's going to not give you a pH, it's going to give you a pOH. So let's just do that real quick. And so let's find the pOH. So pOH is going to equal the negative log of the other one, the hydroxide. So 4.3 times 10 to the negative 11th. Okay, so let's go do that. So we're going to go log, and we're going to go 4.3, and that's going to be to the negative 11. Close that up. Oh, that's 10.36, so we're just going to call it 10.4, or we'll just maybe make it, it's about 10, right? So the answer to this is basically 10. Okay, but that's pOH. And so what you do is you take 14 minus pOH, that gives you pH. Or 14 minus 10 equals 4. Well, if you look, that's pretty much 4. And if I would have used all of my decimal values, if I hadn't rounded, remember that the answer that they gave us on the other page was basically 10.4. Well, if you take 14 minus 10.4, you're going to get the 3.6. So just another way to do it. It's way more steps because you got to do the 14 minus, but you can find pOH and then take 14 minus that value, and it will give you pH. So these things are all going to kind of work together. So I'm going to kind of clean this up, and I'll do one more and then let you guys solve the rest of them, see how you do. So let's clean that up and rewrite it real quick so you have a nice clean one. So we said that this was 4.3 times 10 to the negative 11, I believe, and then this was 3.6. So we can go check that real quick. Yep. All right. Now, acid or base, the way you look at that is you just look at this number, pH. If your pH value is going to be less than 7, then that's going to be an acid. If it's greater than 7, we call it a base. So let's go ahead and do another one. Let's do one where they gave us the other piece right here. So look at D. So we got the other piece right there. So same trick. Let's go ahead and do 1.0 times 10 to the negative 14th. You're always going to start the same way. Equals. This is going to be my H3O plus, which I don't know, multiplied by hydroxide, which I do know, 7.8 times 10 to the negative 12. All right, so what we're going to do here is just get rid of this and replace it with an X. So we'll put an X right here. and we just solve for x. So pretty straightforward stuff. Solve for x right there, and you're going to get your value. So let's go 7.8 to the negative 12. We got to remember that. 1.0. Oops, that's not a 1. There we go. 1.0. And we're going to make that to the negative 14th, and we're going to divide by, so let's check in, 7.8. Okay, divide by 7.8, and that was to the negative 12. So 7.8 to the negative 12, make sure it's correct. It is. I'm just plugging this in. Okay, so let's go ahead and see what we get. Now in this one, you'll notice it didn't give you scientific notation, and you do need scientific notation, so we really need it to be, the decimal to be moved over. So we're going to move it over 1, 2, 3 spots. So it's going to become basically, if I move it over 3 spots, 1, 2, 3, it'll become 1.3, and I moved it 1, 2, 3 spots. So 1.3 to the negative third. So remember, I said that we needed the exponents to add up to, you needed them to add up to negative 15. They do. If we look, negative 3 and negative 12 are going to add up to negative 15. Okay, so that's a good thing. Now, we want to find our pH, so we're going to quickly set up that formula. So that's going to be pH equals negative log, and that's going to be of, remember I said you can only get pH from this value, so I have to use the number over here, and that's going to be 1.3 times 10 to the negative third. All right, so let's go plug that in our calculator. We're going to hit the log button, 1.3 to the negative third. We hit enter. We get negative 2.8. I'm going to make that 2.9. I'm going to drop the negative sign. So right here, I'm going to put 2.9. It's less than 7. So I would go ahead and say this one is also an acid. So that's really going through multiple things, how you find hydronium if you have hydroxide. So how do we find this or this if we only have one of the two? So they will always give you one and you find the other. And then how do we use that information to get pH? And then how do we get that into an acid or a base? So that's really kind of sums everything up. What I would like you guys to do now is I would like you to finish up the examples, see how you can do, follow along what I've done here. It won't be any different, just going to obviously be different numbers. And so go ahead and finish out the chart, and then I'll go ahead and go over those answers with you in class. But that should give you a little bit of practice to kind of see how you do. So, all right. We will see how you do, but just go ahead and finish that chart and see how you did there. So, I'm going to end it here.